Okay, I am going to make a quick video here showing three sort of typical problems of the type that were at the end of the last quiz. So just to give you more chance to sort of get your skills honed. Alright, so this is one in which x is going to infinity. Really pay attention to, is this going to a fixed value that's close to an asymptote, or is this going way out to the right or maybe way out to the left? Because they sort of fit in different categories. So this is the limit at infinity as opposed to an infinite limit. Looking at this is a very easy one to kind of eyeball. You just ask yourself, who's going to win, the top or the bottom? The highest degree in this case is going to win. 5 is bigger than 4, so you can ignore these basically and just cancel, and you wind up with something that's the same as x over 1 when you cancel 4x's top and bottom. Well, what happens when x gets really, really big? Big over 1 is still super big, so this is going to go towards positive infinity. Alright, because if that were going towards negative, then you'd have a negative number because it's odd and it would go towards negative infinity, but it isn't, so it ain't. Now if somebody says, if I say on a quiz or a test, or some future professor says this, explain why, then you can kind of do that multiplying, I guess I'll write it down here, multiply top and bottom by 1 over x to the 4th, and 1 over x to the 4th, whoops, 1 over, and actually no, I like 1 over x to the 5th. Always go to the highest degree, and my pen is super bleeding here, so I can write this again more clearly. 1 over the highest degree, that's x to the 5th rather, and 1 over x to the 5th. Well, when I multiply this into the top and into the bottom, what you're going to wind up with over here, you'll see, is just x over x to the 5th. Right? I'm just multiplying this fraction in all the way to each term, plus x to the 3rd over x to the 5th, plus x to the 5th over x to the 5th. And then in the denominator, same thing, only different numbers on top, x squared over x to the 5th, and then plus x to the 4th over x to the 5th. Well, you're going to cancel x's now, and you're going to wind up with 1 over x to the 4th plus 1 over x squared plus 1 all over 1 over x to the 5th minus 1 over x to the 3rd, and then plus 1 over x. Well, now you're taking the limit of each one of these. It's going to be the limit as x goes to infinity for each one of those. So what happens to that as x goes to infinity? Well, it goes to 0. What happens to 1 over x squared as x gets super big? That goes to 0. But 1, as x goes to infinity, stays at 1 because there's no x in it. Here, this one goes to 0, minus that one goes to 0, plus, and this one goes to 0. So you end up with 1 over 0, but it's getting closer and closer and closer to this as we go towards 0 from above. These are always going to be plus numbers. Alright? So that gives you positive infinity. Moving along then, we've got one here that is the limit as now x goes to a fixed number. So this is maybe getting close to an asymptote. That's the suggestion. Let's find out. So this is going to be an infinite limit. If you see any trig function, I guarantee you all you're going to need to know is the sine and the cosine. Alright? So just remember that the cosine function and the sine function have distinctly similar shapes but different phases, as it's called. Cosine starts at 1 and goes back to 1 after 2 pi from 0 and has a maximum of 1 and a minimum of -1. The sine value starts at 0, goes up and down through a cycle, again in 2 pi, starting at 0, again going up to 1 and down to -1. Halfway along is pi. That's pi. This gets to 0 at pi over 2, and then 3 pi over 2. So what's happening, whoops, I think I went right off the screen there, talking all that time, sorry. And so this is your cosine, know this. This is your sine. Every educated person should know their basic sine and cosine parameters. But we're going to apply it now over here because x is going closer and closer to pi over 2, but from the right. So that means this value for pi this value for x is kind of going closer and closer and closer right there towards that point, which is 0. All right. And sorry, we're doing tangent, but tangent is sine of x over cosine of x. So I just need to ask myself, what's happening? This is going closer to 0 from below, from minus. And here, this, as we're getting closer and closer to pi over 2, from above, that's getting closer and closer to 1. But again, in this case, from numbers that are smaller than 1, getting bigger, so that's from below 1. Now what happens here is that this is, sine is going to 1, while cosine is going to 0, and this is a negative number because it's coming from below, and this is positive but coming from slightly below, but still it's like 0.999. So this is going towards negative infinity. Now, if you want, so back to this one now, this is like saying what's the limit as x goes towards infinity, goes towards negative infinity of e to the x. Well, as this number gets bigger and bigger and bigger but is negative, this definitely goes towards 0. All right. In other words, if you can remember what the exponential curve goes like, it goes like this. That's through 0, 1. But I'm just getting closer and closer and closer to negative infinity like that. So it's getting closer and closer and closer to 0. So that's your answer. All right. Last one here. Sine of x over x squared. Well, as x gets really big, the sign of some big number is still only going to go between plus and minus 1. So at most it'll be plus 1 squared, which is 1. At the smallest it would be 0, because any negative number going to negative 1 will be squared. Again, think back to what values you get in a sine function. It's just going like this forever, staying between 1 and negative 1, plus 1, negative 1. But this value is going towards infinity. So a fixed number over infinity is going to be really, really small, going towards 0. Okay? There you go. 3 straightforward problems.